Welcome to this course, Software Engineering. We will be looking at introduction and historical part of software engineering. And without further delay, let's start. So, history of software engineering and definition. Let's first define what software engineering is. Is a process of analyzing user requirements and then designing, building, and testing software applications that will satisfy those requirements. So this is a very simple definition where the user requests to have a software built, and as a software engineer, you go analyze the user requirements and then act on it to build a software that meets those requirements. Let's look at a history part of software engineering. It was until 1972 that the term software engineering was coined. It was by Dr. Dr. David Panis when he published the paper on color title or the criteria to be used in decomposing systems into modules. So this was when the term of software engineering first came into being, but before that we had some committees, the NATO Science Committee that used it was on this basis, but it was earlier before the year 1972, but it was more on the same where it focused on designing softwares that are reliable and consistent and have security inbuilt into them. Okay, so and we come now to the before 1970s. We had software, but it was not software engineering. Just we had software programming. It was programming rather than engineering. The engineering principles were not being applied to software. So in before 1970s, we had men and women working on designing systems, and these systems had all components of software and hardware. And before then, men worked on hardware engineering, and women worked on software. It was then called programming. So programming softwares was the work of women before 1970s, and men worked on captivating and during that time hardware engineering. But as you can tell, in this current and age, software engineering is more highly valued than hardware, even though hardware engineering is what enables software engineering to achieve anything nowadays. So moving on, I think software just emerged as a way of ensuring that software builds for the systems are reliable, consistent, and can be maintained and can have a security feature inbuilt into it. into the you can tell in today's world without software engineering then there's nothing that we run, and we have different types of software. So in software engineering, at first when you think of software engineering you might think that it is more to do with the developing software, but it's not. The one that deals with software development is what we call software development. It is in what we call software development life cycle. And in this software development life cycle, the first it has around eight steps, eight stages. And the first is what we call planning and analysis. So let's see this. We have planning and analysis. That's the first part. Then the second part, we have what we call user or requirements gathering. Requirements gathering. Requirements gathering. Then three, we have what we call design. This is where the architecture, software architecture is designed. And four, we have what we call software development. And so as you can tell, as you can see, software development is just inside software engineering. This is where all kinds of software development happens. Let's take an example. There are so many different types of software. We have mobile applications, we have banking, we have web-based applications, we have operating systems. Imagine coming up with a new programming language that involves also software engineering. It's kind of software development that comes up with new programming language, but it's advanced kind of software development. Or if you can trace back to the origins of Python, as you know, Python is just C. It was built using C, so came up as a result of software development using C, and with good principles software engineering. And as you can tell, so updates, that's what we call continuous integration and continuous development. Yeah, so those what parts of software engineering, what we call maintenance, software maintenance and deployment. I think five, we have after developing you test, software testing. Then after testing, we have what we call deployment. Six, deployment. Then seven is what we have what we call maintenance, software maintenance. So these are steps in software development life cycle, and in case you follow each of these steps one at a time in this order, that will be you will be using a model that we call a waterfall model that was used back in 1970s. But right now you can start from anywhere as based on user requirements and type of software you're building. You can start from anywhere, and we have different models. Apart from waterfall model, we have Scrum, we have Agile, that kind of mixes these stages So these will you will look at them in this course in more detail. You will see how these come into being. What I won't be looking at in this course is software development, as this is a specific field. Imagine that you as a student following up this course, maybe you have an idea of coming up with of developing a web application, and another student following this course has an idea of coming up with maybe some simple operating system. So as you can see, those are diverged field and require specific tuning. What is consistent or what is common in software engineering, despite any software development that you might be developing, are the processes that we are going to look at. So I just want to let you know that we'll be looking at the principles rather than this actual process of development of software. Okay, moving on. Why study software engineering? Software engineering is nowadays coupled with physical processes. Can you imagine autopilot? So software engineering is as good as autopilot, and if anything goes wrong, you can tell that disaster happens. As I have highlighted here, I have highlighted this course that are associated with inadequate software, or rather testing that was not done in accordance with the principles of software engineering. Let's take an example. You might have heard of Google Bard AI, as it was asked the new developments of James Webb Telescope, and it gave a wrong answer that it was the first telescope to take images on exoplanets outside, solar outside our solar system. An exoplanet is a planet outside our own solar system. So it gave a wrong answer, and that cost Google $100 billion. Just imagine that. And this, it was inadequate training of the AI, and this is what we call hallucination in AI, as far as AI is concerned. Then, back in the years, we had NASA Mars Climate Orbiter. This was an orbiter that was launched, and it was going to Mars, but it got lost due to the engineers that were working on software. They used different measurements. Some of engineers used metric, and some used English, kind of units of measurements. And so these caused inconsistency in data interpretation in the software, and that's how the orbiter got lost. Another one is what we call the Mariner 1 spacecraft. This was a spacecraft developed, and it was going to explore Venus. It was on board Atlas rocket, and in this rocket we had a guiding system that had guiding equations, and one character was missing in the equation, and just 4 minutes into the flight, the Atlas rocket blew up, and with it, the Mariner 1 spacecraft was gone. So these are just few examples of what happens when when you don't adhere to all software engineering principles in this so-called climate orbiter and Mariner 1 spacecraft. The issue was more of testing. Testing was not done inadequate, and also that goes for the AI's data was not. It was not given adequate data. I think that's just my suggestion, just my subjective view of the what happened. Okay, so I think this is it about software engineering and introduction. And this is a course designed to give you the principles of software engineering that you can again use in your field when you are developing your software. Actually, software development works in teams. It's rare that you as a single entity can come up or can develop software personally. It's more of collaboration between different individuals, stakeholders, programmers, and developers. Those are what we call developers. And just imagine Microsoft's Office. It has more than 300 million lines of code, and no one can program that, can develop that personally. So you have to collaborate with others. So collaboration is very key when it comes to software engineering. This course is just designed to give you some ideas, principles used in software engineering. And once you're done, it's a course. It's worth. It's like it costs around $30, and when you're done, you'll be given a certificate of completion that will enable you gain an upper hand when it comes to job seeking and employment opportunities, and also just as an achievement of your time that you've taken to go and pursue this course. There is a link here that you can follow, and I hope to see you there. And the course is detailed. I worked on keeping it text based, so hope you will get utmost out of it, and I will see you there.